Hi friends, welcome to SriSai IT Hub. In this video of Core Java Programming, we are going to discuss the following topic: Hashtable-class in Java Collections Framework. So first of all, we'll understand what are collections framework in Java. So Java collections means collection of objects or group of objects as a single unit or single object in Java program. Then what is framework? So framework means it is a library which is provided by Java to work with collection of objects in Java collections framework. And this library is provided to us in the form of java.util package. So in this java.util package, we have different classes and interfaces using which we can work with collection of objects. So in collections framework, we have collection interface, which is a top level interface or base interface for different classes and interfaces which are available in Java collections. So under this collection interface, we have four popular collections. They are list collection, second one set collection, third one queue collection, and fourth one map collection. So list, set, queue are inherited from collection interface, whereas map collection, it is not inherited from collection interface, but still it is part of java.util package and collection framework. So coming to some technical points, so collections is only for objects but not primitive data types. It means if we store any primitive data type value also, internally it will be stored in the form of object only. And in collections, every data is stored in the form of object itself. And to be more precise, it will be stored as object class, object format, where object class is a superclass for all the classes in Java. Right. So now coming to the concept of hash table class in Java collections framework. So hash table class is available in java.util package. It is inherited from map interface and dictionary abstract class. So coming to map interface is not inherited from collection interface, but still it is part of Java collections framework. So if we see the description of hash table class, java p -p java.util.hashmap, open the command prompt and give this command. So hash table class is inherited from dictionary abstract class, and then it is also inherited from map interface. Right. So next, if we see dictionary description, so in dictionary class we have some methods like size, isempty, keys, elements, get, put key comma value, and remove a particular key comma value from the collection. So our hash table class, so this is inherited from dictionary abstract class. Right. So now coming to hash table class, it is clonable, serializable. It is both clonable as well as serializable. So both are inherited methods. So clonable means we can create a duplicate hash table using clone method, and serializable means hash table object can participate in serialization and deserialization process. And next, one important point, it is a legacy class. So what is legacy class? A class which is clonable, serializable, and methods are synchronized. So if you see here in hash table class, the methods are synchronized. So when methods are synchronized, hash table class can be used in multi-threaded application. Right. So this is what is coming to some technical points. What is hash map? So hash map is a collection of objects storing data in the form of key value pairs. So same like hash map, it will also store the data in the form of key value pairs. For example, key 1 value 1, key 2 value 2, key 3 value 3. So every value is mapped with a key, and here all keys are unique and values can be duplicated, and its initial default capacity is 11. initial load factor is 0.75, which is 3 by 4. So load factor decides the capacity of the hash table. It decides the capacity of the hash table. For example, let us say 11 into 3 by 4. So 11 into 3 by 4, if we calculate this, so 11 into 3 by 4, which is equals to 8. So when we add 8th object, automatically the capacity will become double. So 11 plus 11, which is 22. And in hash table, we don't have indexes to the collection of objects, and hash table does not accept duplicate objects, which is especially keys. Values can be duplicated. And here order is not preserved. We don't have any ascending order or descending order also. And then it does not accept null values. So if we give either null key or null value, we get a null pointer exception, right? And finally, it represents hash table data structure. So it represents a hash table data structure. Right, now coming to the constructors and methods, it goes like this. So if you see the description of the class, java p -p java.util.hashtable. So go to the class, right? So hashtable class, right? This is the default constructor with the initial default capacity of 11 and load factor 0.75. So this is another constructor with int as parameter, which is the given capacity, and default load factor 0.75. So this is another constructor with given capacity and given load factor, and generally the load factor is given as 0.0 to 1.0 and preferable is 0.5 to 1.0. Right, now coming to the methods, we have size is empty, contains value, contains key, contains any value, get key, it will return a value, and then put key comma value, remove key, it will remove key value pair, and then clear clone. So these are some basic methods which are available in hash table. So let us try to demonstrate this with a small program. Hash table class example1.java. So coming to the program, we'll take a new page. So first we'll write the comments. Program to demo hash table class with collection of key value pairs. Import java.util package and then take the main class with main method and save the program in your working directory as hash table class example1.java. So initially we'll create an object of hash table, ht is equals to new hash table, and then we'll add some key value pairs. So here we are adding int comma string, but internally it will be stored as object format only. To be more precise, object class object format. So we are adding 10 Java, 1 Oracle, 11 .NET, 9 Python, and then 3 HTML. So we'll print hash table.size 5, hash table.isEmpty. So is it empty? False. So we'll execute till here. We'll put a comment for the remaining cases. Right. So let us save this program. Come to the command prompt. Compile the program. Hash table class example1.java. No error. And run it. So 10 Java, 9 Python, 3 HTML, 1 Oracle, 11 .NET. So size is 5, is empty, false. So if you see here, order is not preserved. 10, 9, 3, 1, 11. So the order what we have added is 10, 1, 11, 9, 3. Right. So let us perform. remaining operations. So next we'll say hash table dot put 9 php. So 9 key is already available, so it will replace 9 Python with 9 php, and then after that print hash table once again. So save it, recompile and run. So 9 Python is replaced with 9 php. So next 6 php, it is accepted without any replacement because values can be duplicated but not keys. So recompile and run. So 6 php. Next, null testing will get a null pointer exception because it does not accept single null key, single null value. We'll get the null pointer exception, right? So similarly, if we try to add null value, then also we'll get a null pointer exception. 50 null. Recompile and run. So during execution time, we'll get a null pointer exception. So similarly, we'll add one more object, 8 Python, it is accepted. So recompile and run. So 8 Python, it is accepted, and order is not preserved, and order is neither ascending order or descending order, right? So next we'll add, okay, we'll get data for a particular key. So get of 10. For 10, what is the value? Get of 9 and get of 55. So 55 is not there. For missing key, it will return null, right? So recompile and run. So 10 Java, and then 9 PHP, and then null for missing key. So similarly, we'll also check for contains key, right? So contains key 1, true. Contains key 55, false. 55 key is not available. Recompile and run. So true, false. 155. So contains. So contains will directly check for a value. So hash table dot contains 10. We don't have 10 value, false. Contains value, Java, true. Right. So contains is the method. It will directly check for the value. Recompile and run. So false, true. 10 Java. So similarly, we'll also check it for contains value. It will directly check for the value, same as that of the contains method. And then contains value Java CSS. So Java is there, CSS is not there. So recompile and run. We should get true and false. So true and false. Right. So similarly, remove. We'll try to remove a particular object. So remove 11. So 11 corresponding value will also be deleted, and then print hash table, and then try to remove 55. So we don't have a 55 key, so it will return null. So remove 11. 11 is .NET. So recompile and run. So 11.NET, it is removed from the hash table collection, and then remove 55, which is not there. Key is not there, it will return null. Right. So next we will try to perform cloning of hash table. It goes like this. Hash table.clone, it will create a duplicate hash table. So its return type is object class. Convert that into hash table class and store that in a reference variable new ht of type hash table. Print new ht dot size. So save this, recompile and run. So this is the new hash table with 6 elements, and then size is 6. And then finally we'll try to perform clear. So clear will remove all the elements of a hash table at a time. So new hash table dot clear, all elements are deleted. Print new hash table, no elements will be there. New hash table dot size 0. New hash table dot is empty, true. So save it, recompile and run. So no elements, size is 0, is empty, true. So this is how we are supposed to work with hash table class in Java collections framework. Thank you for watching this video. Do like, comment and share this video, and also subscribe to the YouTube channel Sri Sai IT Hub. Have a nice day.